Hello student, welcome to the one more session of Introduction to Embedded System. This is Vasan Naik from Canara Engineering College. In this class, we will study the sensors and actuators. In the previous class, we understood the different types of memory such as ROM and RAM. What are the different classifications of ROM? What are the different classifications of RAM such as SRAM, dynamic RAM, then NVRAM. So similarly, the classification of the ROMs are PROM, one-time PROM, programmable ROM, mask ROM, flash ROM. All these things we studied and you understood the memories. So, so in this session, we will see the sensor and actuator. Actually, I told in my previous session, the sensors are the input device which gets the input from the external world or the other environment. So, and actuators are the output device which is connected to the output pin of the microcontroller or microprocessor. So sensors are connected to the input port of the embedded system. Actuators are connected to the output port of the embedded system. So, an embedded system is in constant interaction with the real world. That means it is getting a continuous input from the real world. This is possible if it is connected with the various types of sensor. So, a sensor is a transducer device that converts energy from one form to the another form. So, energy from one form to the another form. You can see here. So, energy from one form to the another form. So, different types of sensors are available. So, I have here two examples. One sensor is used in pedometer functionality to count number of steps, and other sensor which is known as ambient light sensor, which will sense the intensity of the light. Both sensors are used in various applications. Now, so in the previous session, we understood an embedded system is used for controlling purpose and for monitoring purpose. So, an embedded system which is used for monitoring purpose cannot change the state of the variable. Similarly, an embedded system which is designed for controlling purpose will produce some changes in the controlling variable to bring the controlled variable to the desired level. So here you can see, like, if the embedded system designed for controlling purpose, the system will produce some changes in the controlling variable to bring the controlled variable to the desired level. It is achieved through actuator. So now what is actuator? Actuator is a form of transducer device, either mechanical or electrical, which converts signal into physical action. So actuator is an output device. Like you can see here example, a smartwatch uses ambient light sensor to detect the surrounding light intensity and uses an electronic actuator circuit to adjust the brightness. Similarly, we have one more example here. You can see here. We have one more example here, like temperature sensing sensor here in this diagram. Temperature sensor detects the heat, and this information is passed to the controller, where it will be processed by the microcontroller and microprocessor, and after that necessary changes will be implemented through the actuator. Here in this case, sprinkler turns on and puts out the flame. So such type of application where sensor acts like an input device and actuator converts the electrical signal into physical action. What physical action it will take here? It will turn on the sprinkler and it will put out the flame. So that is the main job of the actuator. Now, the embedded system which is designed for monitoring, which can only monitor, which cannot do the changes in the system variable. For example, you have ECG machine. It is designed to monitor the heartbeat status of the patient, which contains set of electrodes. All these electrodes are connected to the body of the patient, and variation in the particular parameter will be captured by the sensor and presented through the display to the doctor. So it will not, it cannot impose control over the patient heartbeats. It cannot impose control over the patient heartbeats and its order. So it cannot impose control over the patient's heartbeat and order. So this is the example for the embedded system, which is used for only monitoring purpose. Now you see here the difference between a sensor and actuators. Sensor is an input device, actuator is the output device. We know sensor converts physical parameter into electrical output. This actuator converts electrical signal into physical output. So convert physical parameter into electrical, converts electrical signal into physical. So it is a device that detects the events or changes in the environment and send the information to the controller. It is a component of a machine that is responsible for moving and controlling mechanism. Then the last point here is so sensor helps to monitor the changes in the environment, like helps to monitor the changes. So sensors are adopted in various applications. So to monitor the changes in the environment, actuator helps to control the environment or physical changes. So other than that, we have I/O subsystem. I/O subsystem of the embedded system, which will help for the which will facilitate for the interaction of the embedded system with the external world. Now we will see different types of actuator and sensors. So first we will see the actuator, that is a light emitting diode. We know light emitting diode. So we know light emitting diode is an important output device or actuator. So this light emitting diode is used in many applications, like to indicate the presence of a power condition, like device on or battery on or charging of the battery. All these will be indicated by the light emitting diode. Now what is a light emitting diode? What is that? It is a PN junction diode. You can see in the diagram here, it is a PN junction diode. It has got two terminals. The long terminal is called as anode or positive terminal, and the short terminal is called as a cathode or negative terminal. So the long terminal is connected to VCC through current limiting resistor, and the cathode is connected to normally to the ground. So this LEDs can be interfaced to the this LED can be interfaced to the port pin of the processor or controller. Suppose if you connect this positive terminal to the port pin of the controller and negative terminal to the ground, then if the positive pin of the that is anode to the port pin of the controller and port pin of the controller is in logic level 1, then this LED will glow. Suppose if you connect this negative cathode to the port pin of the controller and this anode to the VCC, and if the port pin is at logic 0, then this LED will glow. So you need to remember this one. To glow the LED, either you need to connect this one to the port pin of the controller or this one to the port pin of the controller. When you connect this one anode to the port pin of the controller, if the port pin is at logic 1, LED will glow. If the port pin at logic 0, LED will off. But if you connect cathode to the port pin of the controller, then if the port pin is at logic 0, LED will glow. If the port pin at logic 1, LED will off. LED will remain off. So next we will move to the next one, that is 7-segment display. 7-segment display. So in the 7-segment display, 7 segment LED display, we are using 8 LEDs. Normally 8 LEDs connected in this fashion. Here you can see there are 8 LEDs connected in this fashion. This 1, 2, 3, 4, 5, 6, 7 and 8. These 7 LEDs are used to display alphanumeric character, and the last LED is used to display decimal point. So these LEDs are connected in a segment form, and these LEDs are named like A, B, C, D, E, F, G and decimal point. So you need to start this in start the naming in the clockwise direction, like A, B, C, D, E, F, G and decimal point. Suppose we need to suppose if I want to display 3, then the segment A, B, C, D and G should be lit. So suppose I want to display 3, the segment A, B, C, D and G should lit. Suppose if I want to display 0, then segment A, B, C, D, E, F should lit, G should off. So 7 segment display, there are 2 different configurations. One is called as common anode configurations, other one is called as common cathode configurations. So in the common anode configuration, all the 8 LEDs are connected in this fashion. That is, all the anodes of the 8 LEDs are connected to common anode to VCC. In common cathode, all the cathodes of the 8 LEDs are connected to the common point and to the ground. Suppose in the common anode, if I want to glow this LED, here you need to give logic 1. In the common cathode, if I want to glow this LED, you need to give here logic 0. So this is the difference between common anode configuration and common cathode configuration. So the next device, that is actuator, is optocoupler. So what is this optocoupler? Optocoupler is a isolation device which will isolate actual 2 circuit. So it will isolate 2 parts of the circuit. So optocoupler is made of like LED and phototransistor in a single chip. And this is the example, or this is the conventional chip available in the market, PC817. It is an optocoupler. So why optocouplers are used? Optocouplers are used in communication industry to suppress the interference, that is noise, in the data. Second one is it can be used for circuit isolation, and this optocoupler can be used for in some application like high voltage separation, and simultaneous separation and signal intensification applications also we are going to use this one. Optocoupler is used in either input circuits or output circuits. So now we'll see here, we have one circuit diagram here. You can see in the circuit diagram, this is the microcontroller and this is the optocoupler. So we are using microcontroller AT89C51. And these are the port pin of the microcontroller which is connected to the optocoupler on the both end. And here you can see input circuits are connected to the optocoupler and output circuit is also connected to the optocoupler. That means microcontroller is separated from the input circuit by means of this optocoupler. Similarly, the output circuit is separated by the microcontroller by means of this optocoupler. So here whatever input comes, this optocoupler will transmit that input to the microcontroller. Microcontroller process that input and transmit the output to the output circuits through this optocoupler. So the example for this optocoupler is MCT2MIC. So students, with this we saw some of the input and output device like sensors and actuators. In the next class we will see the other device like stepper motor, DC motor, keyboard, and the working of all these devices in the next session. So So with this, I will wind up this session. Thank you for your cooperation. Thank you.